Testing. Hello, everybody. Should be live. Here's my alarm. And let me just get a little bit set up here. If you're already in the chat, let me know maybe where you're watching from, if you've ever done machine learning before, why you're interested in AI explainability or machine learning monitoring. It's always fun to hear a little bit more about the audience, both for me, but also everyone else watching, I think, as well. Looks like my screen share is working. How's everyone doing today? It's also nice if you want to just let me know in the chat that you can hear me and see me. It's always nice to double check there as well. Someone said hello from Portland. Awesome. I think you've been here before. I think I recognize your profile picture. Welcome back. And I'm always up for if you have any food recommendations in Portland, where I should go next time I'm down there. And we'll get started in just a minute. Gonna wait just like one more minute to get started. And again, for everyone joining, feel free to say hello in the chat. It's fun to see where people are watching from, maybe what your experience level is, if you've been doing machine learning for a while, why you might be interested in machine learning monitoring. Let me know all those things in the chat. And we'll get started in a minute. I think a good question, too, to answer is, have you ever put machine learning in production? Someone said hello. They're a data scientist. Welcome. Have you put machine learning in production? I feel like probably, some people have, or many people have. Or maybe you haven't even put it in production, but someone on your team has. And just while people are joining again, well, now I'll share the links in a second. All right, I'm going to go ahead and get going. Welcome, everybody. This is part 4 if you've come to any of the series in the past, but it's okay if you haven't come to any of the other workshops. We'll recap some of what we've done, and this is kind of standalone. We'll go through and get our kind of code or model back to where it was in the last workshop. We'll go through that very quickly, and then there'll be new stuff around AI explainability in this workshop. And someone said they hadn't put machine learning into production, but people on the team have. Yes, I think that's pretty common, right? A lot of companies will have a data scientist or a machine learning researcher, engineer. You might make the models, and then someone else is putting it into production. And today we're going to talk about understanding ML models with AI explainability and monitoring. And what this workshop is, hopefully it's a friendly introduction to ML monitoring and explainability. So again, this is kind of part 4 of a series. We've been going through looking at all these different monitoring concepts, which we'll do a quick recap on. And this is kind of designed for, no previous experiences expected. Definitely knowing some Python and machine learning will help, and you'll kind of understand the concepts a little bit better. And today we're going to cover some recap of high-level concepts, and then we're going to go and implement examples. So we're going to go through, talk about some of the tools, high-level concepts around AI explainability, and then we'll actually go and do some code after the slides and get some hands-on experience. And then also just keep in mind, this workshop isn't that long, 30 minutes to 45 minutes, however long we go and how many questions there are. You can't learn everything in that amount of time. There's so much in the AI explainability field, so hopefully this will be a fun way to kind of get started and learn some parts of it, and I'll point you places to go, and then you can keep learning from here. And I have a really good resource that's in the notebook. That's a really great book that is all about AI explainability that came out, I think November last year or something, so it's very new. It has a lot of great stuff in it, and that I think it's just called Explainability for AI Practitioners or something like that. It's a great book if you want to dive a lot deeper than we're going to go today. A quick introduction. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. We create tools around ML monitoring and data monitoring to ensure that your pipelines and your models in production are robust and responsible. And again, if you've been at some of the past workshops, we've already gone through things like monitoring for data drift, data quality, model performance, and then the last workshop we even looked at bias and fairness with segmentation in our data. For the last decade or more now, I've worked in the software or hardware industry, mostly with startups and agencies around Seattle and Central Florida. And I love making things with technology. Always have a ton of side projects going on. About you. So again, more people have joined since the beginning. I always like to ask, where are you watching from? Why are you interested in ML monitoring or explainability in this case? And then if you want to stay connected, I'll share this link in the chat. This is a Slack channel where you can stay connected with the other, AI practitioners. I'm in there. It's a great place to ask questions after the workshop. And there's an introduce yourself channel. So if you want to introduce yourself in there, you can. And if you're watching on YouTube, all the relevant links for this workshop, including the Slack link and the notebook and everything like that, are in the description below. And then I will cross-share these links on the LinkedIn stream because I don't think they're in the description there. So let me share this link over there. Make sure LinkedIn is streaming. There we go. All right, so feel free to put in the chat, again, like I said, why are you interested in ML monitoring? Another good question, like I said at the beginning as well, was have you ever put ML in production? And maybe share some of your experience if you have. All right, so quick setup for today's workshop. Again, like I said, we're going to go through some slides, and then we're going to do some hands-on parts. So if you wanted to follow along here, the only thing you'll probably really need to do that you might not already have is signing up for a free YLabs account. Otherwise, we're going to be using Google Collab, which is a Google product, and you probably already have a Google account, I'm guessing. So that's the only other account that you'll need. And the YLabs one, again, is in the link in the description on YouTube, and it's easy to sign up. There's no card or anything required. So it should just take you a few minutes. And we'll come back to this again when we get closer to the code part where we actually need it, again, if you want to sign up. And then we're going to be using scikit-learn to train a model. We're going to be using an open source project we maintain called YLogs, which does data profiling. We've covered this a lot more in the first workshop, where you can actually use it in your Python environment to detect drift and data quality issues directly there. And then we're going to use SHAP. We'll talk about this in a minute, but that's a popular library around AI explainability. And then we'll use YLabs to send some of these explainable values to, so we can monitor them over time and compare them with other models in production. So a quick recap on what is ML monitoring. And like I said, we've kind of covered most of these already. If you've been back in the other parts, we often want to monitor our data input to our models. That allows us to catch things like schema changes, data quality issues, data drift. Model outputs, we can detect if our model is kind of growing stale and not having the predictions that we want anymore. What's the volume coming out of the models? And then model performance, the things you might think of like accuracy and recall. How is it performing over time? Every day, is it getting, better? Is it worse? For that, you need your ground truth data. And then last workshop, we talked about measuring for bias and fairness with segmentation, where we can actually slice up our data and model predictions in different ways and see how they're performing on segments. So again, that's really important, and it could be something like you want to make sure that your credit card approval rate isn't biased towards any gender. And then today, we're going to look at explainability. And what is just a high-level concept, again, of ML monitoring. You might have your production kind of pipeline, wherever you're making predictions or training models. You're going to collect various statistics about that. Then you want to analyze and measure those in different ways, and that just depends on what you're trying to measure and where in the pipeline. But the bare minimum that I like to say is you should be measuring the direct data into your model and the model outputs. And that alone can tell you, did the data drift? Is the model maybe less confident in its predictions? And you can get a lot from there with very, not a heavy lift, basically. And then once you have all those stats measured, you want to do the actions with those. So that could be reports and dashboards, analyzing how your model's performing. Could be alerts and notifications. When data drift is detected, send an alert to your Slack or email. Or you can use it to trigger workflow. So I've done a workshop in the past about creating a system where when data drift is detected, kick off an annotation job that outsources annotation. So then you actually have the ground truth, and then you can actually measure the performance on those days. And if the performance drops, you could then use that already annotated data to retrain a model and then deploy it back in production. And then you could even do things like shadow deployment, see if it actually performed better before you actually deploy it so the users use it. So there's a lot of cool stuff. And yeah, if you haven't done production ML yet, there's a lot of cool things you can do there where you're kind of constantly monitoring and updating models in production. And it's very important from what I've seen. And I've done some consultant stuff in the past, like people building proof of concept products and they want to iterate on them very quickly. Having a loop like that set up is very important. All right, so what is AI explainability? And often it's shortened to XAI, so you might see that around a lot. It's a machine learning field that explains how a model makes predictions, and you try to understand the model's behavior, and training data set can help improve those models. And then basically, we'll show this a little bit later, but it can build confidence both for like you as the researcher or company making those models, but also for the user sometimes, depending on what you're showing from your results. So why do we need explainability? Some models, and we'll see this when we get to the hands-on portion as well, some models are easy to kind of understand and interpret. So if you have a decision, a pretty simple decision tree, you can take a look at that and see like, okay, why did it make this decision? But a lot of times, if you're using ML right now, you might have noticed, and it does depend on the field, but a lot of models are getting way more complex. You have a lot of different data. You might have a lot of features. You might be using something like a neural network. And understanding how that model is making decisions is much harder than something like a simple decision tree. So again, it increases transparency and trust in those models. And again, like that could be from you and the company, but also you might be displaying some of those results to users somehow. One thing right now everyone's talking about is, explaining large language models, right? Like if I ask ChatGPT something, why did it give me this result? So that's a really hot topic right now. And as a user, if you're using something like ChatGPT to answer questions, you actually might want to know why did it say this thing? Because if you played around with it a lot, it loves giving you very confident answers, and it's an amazing tool. Sometimes it's wrong, but you might not know it. So having things like confidence score or explaining why it chose that word, that might be a really good thing to give back to the user in the interface in that case. It can be really important for legal and ethical considerations in certain industries. If you're doing anything in like legal or finance or healthcare, you want to know why your model is making those decisions. Helps improves model performance and accuracy by identifying errors and biases. Again, right, like you might be looking at the feature importance and say, oh, it's using this feature a lot to make a decision, when we wouldn't really do that in our case. And again, we'll look at this a little bit more hands-on and tie it back into how we were looking at biases in the last workshop. I'm going to provide better insight for decision making. Right, as you're training your model, you're putting out production. You want to see, what are the feature importance, or even when you just trained your model, like what are the features that are the most important to the model, and you can do feature engineering around them before you deploy it, and then you can ensure compliance and with regulations in certain industries like finance and healthcare. Actually have things required around this sometimes, like if you have to be able to explain why you made a decision in certain cases. Has anyone done explainability before, or are they like actively looking for it at their company right now? All right, we'll go through some common tools. Sometimes you might not even need a separate tool to do AI explainability. So like I mentioned, you can have a simpler model like a decision tree where you can actually break down why it made the exact decision and then got these predicted classes. And this is great. And a lot of times if you're like an insurance company or something, you might be purposely choosing simpler models, or at least ones with interpretability in them, so you can actually get the output and understand exactly why it made that decision. Because again, certain industries, you have to explain why it made a decision. And you might not need a separate library to do something really complex to understand why that happened, or understand why your model made a decision. So I just want to point that out. You don't always need it. It depends on your model, and you want to be careful about choosing your model in certain industries. And things like scikit-learn with decision trees, we'll actually see this in the hands-on portion as well. They have built-in stuff to give you those like feature importance and stuff that we want to look at, which is pretty neat. Shap values, shapely additive explanations. This is a really popular library. Actually, we'll go out and maybe look at it real quick. It's a really popular library that does a lot of great stuff. We'll be using this today. It gives you a lot of insight about your model. It uses game theory behind it, so you'll feed it your model, you'll feed it the test training data set, and it'll kind of extract which features were most important for those predictions by adjusting things and seeing the output. So you can do tabular data. You can also do image data, which I think is really fun. So if you want to see like, why did it predict that it was a meerkat in this case, or this bird, it actually highlights those important pixels in that image, which is pretty neat. And you find out a lot about your computer vision models in this case, where you might think it thinks it's a cat because of the shape of the ears, but really it's always looking at the eyes or something like that. It's very interesting to kind of look and see how your models are making these decisions, especially in something complex like a computer vision model, where you don't really know unless you're looking at this type of stuff. I'll share this link in the chat as well. It's also going to be in the notebook that everyone will get in a second. But definitely recommend checking out the repo, and it goes way more into details than we're going to cover today. We will use this library in the code portion in a few minutes to get results of our model. LIME, local interpretable model agnostic explanations. They all have really long names. I'm glad they abbreviate them. Here's the link for this repo as well. And it's another commonly used one. It does depend on applications, like we'll talk about in a second. This, I think, is used more for just local feature importance. So that's like based on a single prediction, where SHAP, you can do global and local feature importance. So we'll look at doing global today. We're going to see kind of based on like a general feature importance for all of our predictions versus a single prediction. But SHAP is also computationally expensive. So when you're choosing the right thing to implement here, you'll want to look at like how expensive is it to run, and by that I mean like it can just take a while and compute resources. And then a lot of times there's just a ton of different type of explainability models that can be, or algorithms that can be done directly like in your framework. For example, there's one called GradCam that's really popular and pretty lightweight inside of neural networks or convolutional neural networks. So if you are doing computer vision and you just kind of want to know generally where in the image is the most important features, you could use something like GradCam. So there's a whole bunch of them. I would say from my experience of what I've seen, SHAP is one of the most popular and works across different data types like we had mentioned. But it can be expensive, like we were saying. And also, I think it's after a certain amount of features, like in tabular data, it might not perform well, like 100 plus though. So it depends on which type of data you have. Just like any answer in machine learning, it depends on your data and model. So how do you choose? Again, there are many tools. It depends if you want to do tabular, image, text, right? Like we talked about ChatGPT, there's stuff around transformers. I think SHAP can actually do stuff with transformers now as well. Do you want to measure global importance, local feature importance, and then also efficiency? Those are all things I kind of keep in mind when choosing a model. And then, so in this workshop, we're going to look at global feature importance, and we're going to use SHAP value, and then also we're going to look at doing the kind of the decision tree example there, just getting feature importance with something built into scikit-learn. And then we're going to upload these to YLabs, the tool that we've probably seen before if you've been at this workshop. And we're going to put our values in here, and we can compare across different models and monitor it over time. So enough slides. We're going to get into the code now, and these links are for you to get there. So everyone should open up this Collab link if you want to follow along. Again, it's in the description on YouTube. I'm going to share this in the chat, though, as well, so people can get it on LinkedIn. And then if you haven't already, you can create that YLabs account where we're going to send those values to monitor them. I'll share that in the chat as well. And then I have a new link for you today. If you have been coming to the workshops, there's a survey you can fill out, and we'll randomly select 5 people from the survey, and we'll send you some YLabs swag. The shirt is actually probably going to be this shirt. We have more of these right now, where the no more ML oops. So I'll share this link as well in the chat, and I appreciate if you'll fill it out. And if you want YLabs swag. I also love, I don't have one in my office right here, but these stress balls are really great, and they're really cute. They're one of the better stress balls I've ever had as swag from other companies. So again, I'll give everyone a minute to open up that link. In particular, this Collab link. Once you're here, you want to go to File, Save a Copy in Drive. And then if somebody just wants to let me know that worked for them, that would be great. So File, Save a Copy in Drive will be the most important step to take right now if you want to follow along. And this is going to give you your own copy of this notebook. If you've never used Google Colab before, it's essentially Google's way of hosting a Jupyter notebook. If you've never used a Jupyter notebook before, it's a great way of storing code, documentation like text like this, and outputs kind of all in one place. So it makes it really a cool platform to do interactive programming. So I'm going to go ahead and save my own copy. Should come up like this. Once you have your copy, you can edit all of this, and don't worry, you can always come back to the original one, make your own copy again. Let's go ahead and run this code cell, print hello. This is going to start up our instance. You'll see it's connecting over here. I'll zoom in a little bit, actually. Let me know if that looks good for you, or if you want me to zoom in more. So we see it's connecting. This can take, usually it's just a few seconds. Usually it's pretty fast. And this is Google just spinning up its own kind of instance for us to run all of our code in. It's taking longer than normal. There we go, initializing our instance. And it printed hello. So now we're going to run code. You can also do terminal commands. So if you're familiar with doing terminal commands in Mac or Linux or Windows, like ls lists everything in the directory, you just want to put an exclamation mark at the beginning, and then you can see what folders are in that directory. So we want to pip install one library over here, which is YLogs, which is what we use to profile our data and send that up to YLabs. If you're at the workshops, you'll be familiar. Again, I'll recap this pretty quickly though, and a lot of the code that is kind of from the past workshops, I'm going to run through very quickly, but I can always come back to it after the explainability piece if you found it interesting. So this should take a few seconds to install. Now this is a very important step, is we want to restart the runtime. If we don't restart the runtime, you'll probably get an error later. So if you get an error later, just keep that in mind. If you didn't restart the runtime, that might be the issue. So we'll hit restart. And Google Colab comes already with a whole bunch of pre-installed libraries like TensorFlow, Scikit-learn, PyTorch. So that's why we only have to really install YLogs here. And we saw this kind of initialized again, and now our runtime is restarted. And if you just forked this or saved a copy right now, the right section should already be open. But if you're watching a recording later, this might be collapsed. You can open it up by clicking this little arrow. Maybe the other ones will be open. And again, you can just collapse and open these. So these were all kind of all the previous sections. So again, if you do want to run through any of the previous stuff we covered in workshops, you can always open these up later and follow along as well. So let's pip install one more library in this section. This is going to be SHAP, because that's what we're going to use to look at our model importance, or model feature importance. Again, this should only just take a few seconds as well. And we don't have to restart runtime here. The reason why we have to restart runtime of the other one is because it uninstalled a newer version of a library and installed a new one. So we just had to kind of get the specific version we wanted installed in our instance. Like I said, Collab comes pre-installed with a whole bunch of libraries in there. So again, I'm going to run through pretty fast the next code part because it's stuff that we had already covered. But I will say high level what's happening in each code cell. And then I'm happy to come back to it if anyone has any questions after we do the explainability piece. So here, we're just importing the libraries we're going to use. Oops, didn't mean to make a new code cell. And then here, we're getting our iris dataset. And I always like to say, don't worry, because we're interesting. You're not just going to be training an iris model like you might have done hundreds of times or in the past when you were learning machine learning. Here, we're going to train our model. we're just using a KNN model here, and we're doing our train test split, and then we can see that our model score was 97, almost 98 on our test data. Here, this might look a little crazy here. I'm just importing 7 batches of data. It's just different CSVs, and we're going to use this to simulate running our model in production for 7 days, essentially making predictions for each of those days, and we're pushing those up to YLabs. So the main thing is just remember we have 2 data frames here. We have one that's all the X values, so all the feature values, which is this sepal length, sepal width, petal length, and petal width for all these data batches. And then we have one for the targets, and that's because we're going to get piece together ground truth later to look at performance like we did in a previous workshop. So we ran that. You look at the data frame. That's what it looks like. These are our features today. And then let's go ahead and create a new list of data frames. All we're doing here is passing through each of those batches, and then we are making predictions with our KNN model, and then we're piecing those predictions onto our data frame. So now if we look at our data frame, we have all those features. We have our state, which is we looked at for segmentation last time, and then we have our class output. So this is what the class of the model thinks it belongs to, and then the probability output, kind of how confident it is that it belongs to that class. All right, so one last piece is set up. We want to push these profiles up, and then we'll get to the explainability piece in a second. We just want to go ahead, go to the YLabs platform. If you haven't already, the link is in here to sign up again for free. I'll share it one more time in the chat as well. And the link is in the description. So if you, again, if you're watching on YouTube, all the relevant links here should be available for you in the description. And I'm going to go in. My platform looks like this. I'm going to go ahead and create a new project. You might have 1 or 2 starter projects in here as well if you just made a new account. Go to create project, go to setup model. I'm actually going to go ahead and delete this non-defined test model that I have in here. So you could do this as well with any other models that, like toy models that might already be in there for you. If you want to go ahead and delete them, you can clean it up here as well. So I'll go ahead and delete that. And then I'm going to create a new model, and I want the type to be classification. So definitely set that right here. Make sure your model type is set to classification. We're going to use that when we log our performance scores. And I'll just call this explain workshop, but you can call it whatever you want. Nate, you can always rename this later if you want as well. So I'm going to hit add model or data set. Now we have our new model down here. Yours will have a different number. Mine is model 38. So I'm going to go ahead and copy that, go back to my notebook, and paste it here where this model ID exists. Make sure you have no space. I accidentally copied over a new line or a space there. Make sure you have no new lines or spaces in your sections here. So we got our model ID there. From the same tab, I want to go to access tokens. So just go over here, give an API key any name. I'll just call it API for now. You can set expiration dates on them if you want as well. And I'll hit create access token. And I want to copy over my token here. And I will paste that into this spot. Again, no spaces or anything. Looks good. And then we want to get the org ID, one last thing. That's in a couple places. You can copy it from here. You could copy it from over here. And it's even in our menu over here. So I'm going to copy that org. And I have no spaces. Again, make sure you didn't accidentally copy over a new line or space. And then you should be good to go here. And that should be the last real setup piece for us to do. So go ahead and run this. And I'll give everyone a minute. I know sometimes people want me to go back and show how to get something. So let me know in the chat if you do want me to do that. And sometimes there's a little bit of a delay when I ask that to people watching on streaming. So feel free to answer that. I'll keep going here and talk a little bit about the YLogs profiles and what we're doing here. So if you were at the other workshops, we talked way more about these profiles, but YLogs create something called a profile on your data set. So it looks at the whole batch or whole data set that you pass into it. It profiles it. It gets statistics about it. So we'll actually take a quick look at what that profile looks like here. So this doesn't really contain any raw data anymore. It just has your cardinality, like how many unique values are in there, the counts, the distribution max, the mean, the median, the min, the quantile distributions, and kind of what data type it it is. Like, was it a fraction? Was it an integer? So again, just quickly recapping, profiles are a really cool way to get these statistics. They're secure because they don't have your raw data. They're super efficient because they're super lightweight. You can do a whole bunch of customization in YLogs, so you can go check out that GitHub repo if you want, and always give us a star. We always appreciate it. Link is in the description for that as well. We won't talk too much about this for the rest of the workshop here, but they're just using those statistics, you can do a lot of stuff like detect data drift and data quality issues. So if you go up to that 101 section, we actually do a lot of that in your Python environment. All right, so just a couple more code cells to run before we get to the SHAP values. And this is just kind of catching up to where we were in the last workshop, so that we'll have our data in YLabs, and then we can look at the explainability in there as well. So you can run this, import some data schema from YLogs. Here we're just kind of backfilling that data. So we had this data frame. We're basically just now looping through each of those data frames and logging one for each day. So we'll see this in a second in the platform, but we're getting our feature values, and then we're getting our class output and our probability score for each one. And then we're going to be monitoring those over time. And then just want to mention, it's only a few lines of code to actually write that profile up to YLabs. Here we're backfilling it and passing in a date time so we can get the backfill data on all those different dates. By default, it'll just write at the date and time that you have. So really just a couple lines of code to write these profiles up if you're not backfilling a data frame like we are for the workshop. And then one more section, we'll just go ahead and run these. What we're doing here is now we've appended that ground truth target to it. So now we can do everything from getting our, looking at our features for data drift, getting our probability output and what classes were predicted, and then we'll actually have the ground truth now in the platform where we can measure actual performance on it. And again, we covered these a little bit more in the past, but now we just wanted to get to that state so we can go ahead and add explainability features to our platform, and we'll take a look at how these can all kind of tie together. Just real quick, I'm going to go to YLabs here, hit homepage, and just make sure, that profiles we're uploading. We got green check marks here. If you went and it said no profiles or anything still in here, potentially you didn't put in the right key or something like that, though it should have thrown an error somewhere. But you can just go back and make sure that there's a little green check mark right now, no anomalies in range, and that profiles are being uploaded. If not, let me know in the chat if something happened there. All right, so now that we have our data in YLabs like we had before, let's go ahead and add a new piece to our whole kind of ML monitoring system that we've been building. That's going to be the SHAP values like we talked about. So we're going to make a variable called explainer. We're going to pass in our KNN model and our training data set. And then we're going to get those SHAP values, which allow us to kind of look at things like feature importance for our data. In this case, the SHAP value here, we're going to pass in our whole testing data set. So if you remember when we did train our model, or if you looked closely at the code this time, we used 30% of it was stored as test data. So now we're using that 30% of our original data set to kind of understand maybe why our model is making the predictions the way they are. So if we run this SHAP.summary plot, and we pass in, again, our SHAP values, our test, and then we're saying we want the chart type to be a bar chart, we can actually see feature importance. And now we have a pretty simple model here. So we only have 4 features, but you might have something with like tens or 100 features or something like that, and this would be maybe way more interesting. But here, if you were at the last workshop and we were looking at the biases in segmentations, we actually kind of concluded that, well, there was a big change on the bias data in the petal length. And we can actually see now, using something like SHAP values or some other way to get these types of values, these feature important values, we can actually see that petal length is the highest thing that basically our model looks at to make the decision of what class this belongs to. So having a big shift in the petal length for one of those segments is actually a big deal for us here. If it was in the sepal width, maybe it's not as big of a deal. we could investigate further, see if it was causing the big changes for our model predictions. But here, and we'll look at this again when we go back to the platform, we can see that, if we did have a big change in this petal length values, that is probably really going to drastically change the way that our model does predictions. So let's go ahead. So we have our SHAP feature importance. This is a way of basically just extracting what's shown here from the SHAP values. We're just getting the mean over all the SHAP values. And then here we're basically just making a dictionary. We'll look at what that looks like right here. So now we have a dictionary with those mean values with the feature name on each one as the key. And then go ahead and run this. This is importing some other tools from YLogs here to write to YLabs. We just want to pass in our SHAP values for our feature weights and then write them up to YLabs. And then let's go ahead and go into the YLabs platform now. And I also have links to learn more about SHAP, and we'll go a little bit deeper here in a second, but let's go check out YLabs. Also, if anyone, I know I saw some people from the last workshops. If anyone wants to say in the chat, were they here at the last workshop? So if I go into YLabs, again, this may look familiar. If you were at previous ones, we have all of our kind of summary cards. We can actually see there's an explainability card here now too, telling us our global feature importance, which is pretty cool. We also have our accuracy like we've seen before for our latest performance that we uploaded and how many segments we have. And I'll just recap some of these tabs real quick for if anyone is new here. We have our monitor manager, so you can set up monitors. So if there is a big shift in data or performance, you can get an alert or trigger workflow like we had talked about at the beginning. You can investigate distributions of your profiles here that were uploaded. You can get some cool stats about them, overlay them so you can see like how different is the distribution for each one. This was our input tab. We've looked at this a lot if you've been at previous workshops. Here we can investigate the input data. We can also preview and set up monitors here. So if there's data drift, we get alerted. Here's our output tab. We get our class output predictions for each day. And then the last one, we had added segments. So you can kind of drill down into all those things we looked at, but on specific segments. And then we have our performance tab. So the things like accuracy, again, you can look at these as segments as well. And then we have performance tracing. This is where we found in the last workshop that, our model was a little bit biased towards Florida data. So we might want to take that new data that we collected in production, retrain our model, and then maybe it'll not be as biased towards this data anymore. Now, finally, final tab here is the explainability tab. And this is where we've just uploaded those feature important values to. So now we can store these here and update this whenever we want. So if we did retrain a model and deploy it, you could actually look at the feature importance. And the cool thing is you can also look at how much it's changed. So I have another model up here. You probably won't have another one with explainability in it unless you already ran through this workshop or material before. But here we can actually compare our feature importance between models. So this is really cool. Like I'd mentioned, doing shadow deployment. If you had drift in data, you relabeled data from production, you trained a new model, then you're measuring performance on that model. And you might also want to measure the explainability or feature importance of that new model, how it compares to the old one, and you can do that here. So here, they're very similar. The petal length is both the top for all of them. You can see, maybe you can't, maybe I can zoom in. If you followed along, you'll be able to see that the values are a little bit different because these are different models in production. So the previous one, this was actually a little bit more important to it than our current one. So a cool way of another piece kind of adding to our whole system that we've built now of keeping track of our models and how they're performing. And we can go back to this notebook real quick. And there are some other code cells here, but before I run through all of them, I'll just say any questions on this, or again, does this seem interesting for anyone? And I also saw a whole bunch of people pop in. So I'll just mention real quick, if you're on YouTube, which is where I saw a lot of the people pop in, a link to follow along to everything is in the description below. So including the Collab notebook that we just ran through, you can go run through this a little bit later or catch up right now if you wanted to. And then the only thing you'll probably need to sign up for is the YLabs account. And then I'll share this link one more time, our new survey. So if you want to fill out this workshop survey for a chance to win some awesome YLabs swag, you can do so at this link. All right, so I'm back in the notebook here. I just want to mention again, go to the SHAP GitHub and or look up like a tutorial on it. And there's so many other cool things you can do that we didn't do in here yet. Different graphs you can make to learn more about your data. Look at it in all sorts of different views. So one cool view is this bee swarm 1.2, which we do have in the notebook. So if you run this, and it plots out our SHAP values that we had, but in a way where you can see like how high of an impact that feature value has. So like the higher that feature value is, the more of an impact it has on the model prediction. So there's a lot of really cool charts that you can drill down into how your model's performing on your data, which I think is really cool. Next, we'll just go quickly into the tree and scikit-learn explanation. So kind of like we saw before with a more interpretable model, we'll go ahead and just train a decision tree, very similar to like we did with the K&N model, but a decision tree, and that actually has built-in features in scikit-learn to kind of get the most important values here. So if we look at these values, let's go ahead and create a dictionary like we did before as well. We can actually see, here are the feature importance for our model for that decision tree, which is pretty interesting. So again, pretty similar. I mean, different values here. But if we were to order this in a row, petal length again is clearly at the top, and then petal width, and then sepal length, and then sepal width. And if you wanted to write this type of value up, it's just like what we did above, except for we did the SHAP values up above there. You would just change, I would just change, instead of having the SHAP values here, I would just change this to weights. I messed up there. So you just want to add weights there and then uncomment this, and then that would write up the values to YLabs. And then something like a decision tree is pretty interpretable, especially if it's a simpler model like we have. So you can actually get the plot from scikit-learn. It has a plot tree value for decision trees, and you plot it out, and then you can make it look nicer with matplotlib like we did here, and actually go look at, okay, the petal length was below 2.45, and if that's the case, then it automatically in this case says that the value is class 0, which is one of the classes of flowers. And then you can see how it made the other decisions based on all the other things like petal width and petal length, and we found out that petal length was one of the most important ones here. And that's probably also because there's a whole class that depends on that, right? Like if the petal length is under a certain amount, it's automatically going to class 0. And then over here, it breaks down and puts them in other different classes. And then just a quick wrap up here. So we've gone through, we did, again, super high level, seeing some of the explainability pieces, and a very quick intro at a couple of the tools here. You can fill out this form if you want to get a certificate for the workshop. Again, actually, the link for that might not be in the description. But if you copied the notebook, the link should be in there. But I'm going to paste it in the chat as well if anyone wants to fill it out. And then here's the other cool links. The book in particular, there's a really good book if you want to dive deeper into explainability. It even covers a lot of like emerging topics. And like we had mentioned, doing stuff around LLMs and stuff, right? A super hot topic right now. That's covered in there as well. So that'll be the last link I think I'll share in the chat. Everything else should be in the description. Or if you followed along and saved a copy of this notebook, you can go back to these links anytime you want. Was that interesting to anyone? Do you learn something new? Was it fun? Are you going to try any of these methods out on a model? I'll also share our GitHub link for YLogs if you want to learn more about that. We didn't cover it too much because we wanted to kind of get to the other stuff, but I could go back to it too if people want. And there's still quite a few people here. Actually, I keep seeing new people come in too, which is awesome. Welcome, new people. Links to follow along to everything are in the description on YouTube. So if you do want to go back, I think even live streaming YouTube, you can go back while it's live and follow along by clicking those links. Someone said that was great listening from the UK. Awesome, thank you. And Paul said very interesting. Someone said definitely interesting. That's very exciting. Yeah, I love doing these types of workshops, and I know they're kind of fast paced and high level. Honestly, that's how I like kind of learning things sometimes, is going in, trying out a tool, and then obviously the best way to learn it is go learn more about that tool and put it in, not necessarily production, but use it with your own model. Because today, right, we just looked at a pretty simple iris model, but you can use this on a much more complex model, and you'll probably get some very interesting insights if you've never done something like that before. Same with, doing it on images and different types of data. I think they have the transformer one here too. I actually haven't done it on a transformer yet with SHAP, but I'm pretty sure you can. Yeah, okay, yeah, the natural language examples with transformers. Is anybody doing stuff with natural language processing by chance, or transformers or large language models? Someone said they loved the workshop. Thank you so much for the feedback. Also, since there's so many people here, if you want me to recap anything, let me know. Specifically, I know we ran through really fast because we did a lot of it in a previous workshop. We could take a quick tour at some of the other features here. Specifically, like the bias and tracing like we covered last time, which I think is really cool. And that we can do this because we segmented our data. If we would go back to our code and we look at when we wrote the data up to YLabs, we have this segmentation feature that we called. You don't have to do a segment if you don't want to. But here we're segmenting on the column state. So for each of our flowers, we had which state it was from. And then we could break it down and see how it performed on each of those segments. So this is really cool because I think I'd mentioned the credit card use case, which is something that comes up a lot when people talk about kind of bias and explainability pieces, because it's something that companies have gotten in trouble a lot for. Like there was a big tech company that had a new credit card, and then people found out there was really biased towards I think it was women in that case, and you shouldn't have the gender like that. Like that's not going to be a coded value in your data set, right? It's not going to be that's not going to be a feature the model's making a prediction on. So a lot of times you want to go add like a segment in on your data set to it. So like clumping by gender by that case, or in this case, we weren't making predictions on the state itself. We were only looking at these 4 features, the petal and sepal length and width. But then when we break down our data and look at it in those different segments, we see that in this case, all of our data from Florida across all profiles here is not as accurate as our other data. And if we do select a comparison profile, we can see that's kind of true for most of these days anyway, where all the Florida data is about this low. And if you go back to this performance tab, you could also select another project. Again, you might not have one, but it's cool. You can compare performance between projects. So you could tie in kind of seeing maybe how your model is doing on terms of feature performance. So you could be looking at, all right, like let's say this changed way more. Theoretically, it changed, and it wasn't as prominent on petal length or something like that. You could also look at how the overall performance of that model is. So like, is it more accurate in that case, or is it not? And of course, you can also look at segmentations as well in here, which again, if you want to see, like you can see Florida overall, the board was a little less accurate from our data from that region. And you can drill deeper into segments where you could look at petal length for all these different segments, and we could see that the median In this case, for Florida is like 5.3 for most of them. All the other ones are for like 4.2. So it's like almost a whole digit higher. And that's like we kind of use this kind of troubleshoot why our model might be biased towards Florida in this case. I'm not sure if I understand your question or how to present it, I guess, from this case. So here we're looking at the feature importance, global feature importance. So like in general, this is the way that our model is going to be looking at the features and making predictions. So I think understanding, like, if you were, in this case, I guess the causality, like when we looked at our performance in Florida wasn't as high. And then we drilled deeper and we saw that there was a big change in pedal length. And then if we go look at our explainability and we saw that pedal length is the most important feature, that's a good way of tying back of, well, okay, Florida had a big shift in data for that specific feature. And it's a big reason why it's causing it to be less accurate on it. So a lot of it comes down to kind of drilling down in these different ways of your data and your model predictions. And it's a great way of debugging your machine learning model in production. And these all kind of tie together. So now we've gone through, again, some people are here probably that didn't go through all 4 workshops. But if you did go through all of them, we've gone through basically looking at most of the stuff that you'd want to in monitoring a model in production, whether that's for the data drift, data quality, or outputs. Again, you can, if you don't have the ground truth, you can still tell a lot sometimes by your output. So in this case, there isn't a huge change here. But if you had one day where you're kind of expecting these to be averaged out per day of different class predictions, and then there's a day where there's a big shift there, that could tell you that, okay, well, that probably that big shift in the real life maybe didn't happen. Something might be wrong there. You could look at the probability of your outputs and see how it's performing. And then data input as well is a huge thing. So really just seeing kind of like how your data is looking over time. And then in this case, the data doesn't get crazy. It's subtle on the Florida thing in that specific segment, but there isn't a big shift in overall median values across our data. Like some of the previous workshops, we had a big data shift happen, and that's where we set up a monitor where you can do very easily. You can configure these monitors to look at drift in different ways and tune them here. Awesome. Well, I know we're way over our initial schedule time, almost an hour in, but I had a great time showing people some of the explainability tools and concepts. Hopefully, some of you had a lot of fun as well. I know some people said it was great and they really enjoyed it. So thank you so much for coming out. And I'm going to go ahead and wrap up the stream. But if you have any questions, feel free to connect with me on LinkedIn, or the best place, honestly, is to ask them in the Slack channel that I've linked to, and that's in the link in the description as well. Ask them there. There. With that, I'll wrap it up. Again, thank you everyone for coming out, and especially thank you for everyone typing in the chat. It's always great to have questions and just even hearing a little bit more about what you're working on, or if you found it interesting. I always really appreciate it. So everyone have a great rest of your day, and enjoy implementing monitoring and explainability into your models and production systems. Thank you, everyone.